The Jaguar XK120 was not conceived as a purpose-built sports car in the modern sense. Its existence was largely driven by necessity rather than long-term product planning. In the immediate post-war years, Jaguar, still officially operating under the name SS Cars until 1945, needed a compelling technical statement to reintroduce itself to the global market. That statement was the new XK engine. The car wrapped around it came second. Rather than designing a bespoke sports car platform, Jaguar adapted what it already knew. The XK120 uses a steel ladder frame chassis, derived conceptually from the Jaguar Mark V saloon. Two longitudinal box section rails run the length of the car, joined by relatively simple cross members. There is no central backbone, no perimeter frame, and no attempt at structural triangulation. Torsional rigidity, even by late 1940 standards, is modest. This decision was not ignorance, it was pragmatism. Written in 1947 to 48 faced steel rationing, labor shortages, and export pressure. Jaguar's priority was to get a car into production quickly, using proven tooling and manufacturing logic. A ladder frame was easy to fabricate, easy to repair, and familiar to the workforce. The wheelbase was shortened compared to the Mark V, but the overall architecture remained front-engine, rear drive, with a long front overhang. The XK engine, physically large due to its inline-six layout and dual overhead cam cylinder head, dictated much of the packaging. Although Jaguar pushed the engine rearward relative to the front axle as much as possible, the result was still a forward weight bias, influencing both ride and handling characteristics. The earliest XK120 bodies were constructed using hand-formed aluminum panels over an ashwood frame. This was not a stylistic decision, but a logistical one. Jaguar lacked the capacity for large-scale steel pressing immediately after the war, while skilled coach builders and timber supplies were readily available. Aluminum kept weight low, but the reliance on wood introduced long-term durability issues and variability in panel fit. Each early body was effectively unique. Panel gaps varied, symmetry was inconsistent, and dimensional accuracy depended heavily on craftsmanship. From a production standpoint, this was unsustainable. By 1950, Jaguar transitioned the XK120 to pressed steel bodywork, retaining aluminum only for the doors, hood, and trunk lid initially. This change improved repeatability, crash durability, and corrosion resistance of the main structure, but it also increased curb weight. Importantly, the ladder frame itself was not substantially revised to compensate, meaning overall chassis stiffness improved only marginally. Aerodynamically, the XK120 was shaped by intuition rather than science. There was no wind tunnel testing. The smooth, flowing bodywork, with enclosed wheels, a low roofline, and a long tapering tail, reduced drag compared to contemporary open sports cars. This allowed Jaguar to credibly claim a top speed of 120 miles per hour, hence the model designation. The body mounts to the chassis through rubber isolators, emphasizing refinement over structural integration. This decision reflects Jaguar's mindset at the time. The XK120 was meant to be a fast road car, not a strict competition machine. Flex between body and frame was accepted as a trade-off for comfort. From a production standpoint, the ladder frame also simplified export logistics. The XK120 was conceived primarily as an export car, particularly for the American market. A conventional frame allowed easier repair in overseas markets with limited access to factory tooling, reinforcing Jaguar's post-war export strategy. The heart of the XK120 is the XK engine, and its significance extends far beyond this single model. Designed during wartime and finalized afterward, the XK was intended as a long-term modular platform. Jaguar expected it to power saloons, sports cars, and racing variants for years to come, and it did. The engine is a 3.4-liter inline-six, featuring a cast iron block and an aluminum alloy cross-flow cylinder head. Dual overhead camshafts operate inclined valves, allowing efficient airflow and higher sustained engine speeds than pushrod competitors. This layout was advanced for a production road car in 1948. The bore and stroke, 83 mm by 106 mm, favor torque production over high revving power. Peak output in early XK120s was rated around 160 horsepower, though real-world figures varied, depending on carburation, compression ratio, and fuel quality. What mattered more was the broad torque curve, which made the car flexible and usable on real roads. Fuel delivery is handled by twin SU-H6 carburetors, chosen for their simplicity and reliability. SU carburetors meter fuel based on airflow demand rather than throttle position, resulting in smooth progression rather than sharp response. This aligns with the XK120's role as a high-speed touring car rather than a track-focused machine. The engine's cooling system is conventional but marginal in extreme conditions. A large front-mounted radiator and mechanically driven fan manage heat adequately at speed, but prolonged idling or slow traffic can lead to rising temperatures, especially in warmer climates. Power is transmitted through a 4-speed manual gearbox. First gear is unsynchronized, reflecting pre-war gearbox design conventions. Ratios are widely spaced, relying on engine torque rather than close gearing to maintain momentum. Gear changes require mechanical sympathy, particularly when downshifting into first. From the gearbox, power flows to a live rear axle via a conventional drive shaft. The differential is robust but unsophisticated, with no limited slip functionality. Under hard acceleration, especially on uneven surfaces, wheel spin is easily induced. Suspension design reflects a mixture of innovation and conservatism. At the front, the XK120 uses independent double wishbones with torsion bars, offering improved wheel control and ride quality compared to leaf-sprung setups. At the rear, however, Jaguar retains semi-elliptic leaf springs and a solid axle. This combination results in predictable but not agile handling. The front end tracks cleanly, while the rear can become unsettled on rough roads. Oversteer characteristics are progressive, but heavily influenced by throttle input and surface conditions. Braking is provided by hydraulically actuated drum brakes on all 4 wheels. While adequate for moderate speeds, repeated high-speed braking reveals fade quickly. This limitation would become increasingly apparent as the XK platform evolved and performance increased. Jaguar allowed them to become part of the driving experience. The gearbox reflects transitional engineering priorities. Synchromesh development lagged behind engine advancement, resulting in a driving technique that demands anticipation and deliberate action rather than rapid gear changes. The interior of the Jaguar XK120 reflects its transitional position between pre-war craftsmanship and post-war standardization. It is neither Spartan nor luxurious, but engineered with a clear emphasis on function and mechanical awareness rather than comfort or refinement. Seats are lightly padded and mounted low within the chassis. Lateral support is minimal, but this was consistent with period driving philosophy, which prioritized smooth steering and throttle inputs over aggressive cornering. The low seating position contributes to a low center of gravity and reinforces the sensation of speed, even at moderate velocities. The seating posture is distinctly reclined. Legs extend forward, arms reach outward to a large diameter steering wheel, and the driver's torso sits relatively close to the rear bulkhead. This geometry reduces fatigue during sustained high-speed cruising, but limits leverage during rapid steering corrections. The dashboard is a painted steel panel, finished in body color, with inset analog gauges supplied primarily by Smiths. Instrumentation is limited to essential data: speedometer, tachometer, oil pressure, water temperature, and fuel level. There is no redundancy, no insulation between driver and machinery, and little attempt to suppress mechanical feedback. Switchgear consists of toggle switches and pull knobs, arranged more by wiring convenience than ergonomic logic. Familiarity is required to operate the car efficiently, particularly at night or in adverse weather. Weather protection is rudimentary. Early XK120s used side curtains instead of roll-up windows, and the fabric roof offers limited insulation. Wind noise is constant, and airflow management inside the cabin is largely uncontrolled. Externally, the XK120's proportions define its character. The long hood dominates the profile, visually communicating engine prominence. The short rear deck emphasizes speed over practicality, while the flowing fenders reduce visual mass and frontal disturbance. Chrome trim is restrained and functional. Bumpers are light and offer minimal wheel protection. Wire wheels, typically supplied by Dunlop, reduce unsprung weight and assist brake cooling, while narrow tire widths reflect both road conditions and steering geometry of time. Exterior mirrors, when fitted, are largely symbolic. Rearward visibility is limited, reinforcing the car's forward-focused driving logic rather than situational awareness in dense traffic. Original Jaguar XK120 finishes were typically single-stage cellulose paints. These paints offered rich color depth when new, but limited long-term durability. Over time, oxidation, fading, and micro-cracking are common, particularly on aluminum panels exposed to heat and vibration. When inspecting an XK120, surface appearance must always be interpreted within historical context. Panel gaps on early aluminum-bodied cars were inconsistent even when new. Uniformity matters more than symmetry, and overly tight gaps often indicate later reworking rather than factory accuracy. Corrosion is a primary concern. The interface between aluminum panels, steel fasteners, and the wooden body frame creates multiple opportunities for electrolytic corrosion. Moisture trapped within the ash structure accelerates decay, particularly around doorposts and lower sill sections. The ash body frame itself requires careful evaluation. Cracks, rot, or non-original wood sections can compromise structural alignment. Replacement wood that deviates from original dimensions often introduces long-term distortion that is difficult to correct. Chassis inspection should prioritize suspension pickup points, cross members, and rear axle mounts. The latter frame is robust, but vulnerable to fatigue if the car has been driven hard on poor surfaces. Mechanical inspection focuses on valve clearances, camshaft wear, oil pressure stability, and cooling efficiency. The XK engine tolerates sustained use well, but is unforgiving of neglect. Electrical systems are simple but frequently compromised by aging insulation or non-original modifications. Original Lucas components, when properly maintained, are reliable within their design limits. Many restored XK120s use modern multi-stage paint systems. While visually appealing, these finishes alter surface texture and reflectivity compared to original cellulose paint, subtly changing the car's visual presence. Driving the Jaguar XK120 today requires recalibration of expectations. Performance must be interpreted within the context of late 1940s engineering rather than modern benchmarks. Acceleration is strong once underway, driven by torque rather than engine speed. Steering effort is heavy at low speeds, unassisted and direct. As speed increases, effort reduces and feedback improves, though ultimate precision is limited by chassis flex and rear axle movement. Ride quality favors long-distance stability over sharp response. The torsion bar front suspension absorbs major imperfections effectively, while the live rear axle can transmit harshness over short, uneven surfaces. Braking demands anticipation. Drum brakes provide adequate stopping power initially, but fade quickly under repeated use, reinforcing the need for forward planning and mechanical sympathy. At sustained cruising speeds, typically between 70 and 90 miles per hour, the XK120 feels most at ease. Wind noise dominates the sensory experience, but the chassis remains composed and stable, reflecting the effectiveness of the car's aerodynamic shape. At sustained cruising speeds between 70 and 90 miles per hour, the XK120 operates within its optimal mechanical envelope. Engine vibration diminishes, steering effort stabilizes, and aerodynamic drag becomes the dominant force acting on the car. Driver workload remains high by modern standards. Steering corrections, throttle modulation, and braking all require continuous attention. Rather than isolating the driver, the XK120 demands engagement, rewarding smoothness and restraint rather than aggression. During extended driving, heat management becomes a defining factor. Cabin temperatures rise steadily, and engine bay heat migrates through the firewall, influencing driver endurance rather than outright performance. The Jaguar XK120 was never intended as a racing car. Its purpose was to demonstrate Jaguar's post-war engineering capability in a usable, export-focused package. Its greatest achievement lies in defining a philosophy: advanced engine design paired with conservative chassis engineering, delivered as a fast, usable road car.